Alright, so initially we're going to have the initial angular momentum is equal to the final angular momentum. So you break that up into the initial moment of inertia and initial rate of rotation for the student, plus the same thing for the dumbbell, and the arm is equal to the final moment of inertia plus the rate of rotation for the student plus the dumbbell plus the arm. And then they give you the initial rate of rotation and the initial total moment of inertia. So you add those two, you turn this side, the initial side, into the initial moment of inertia plus the rate of rotation is equal to the final of the student, dumbbell, and arm. And you're going to get the 2.4 times pi equals to the moment of inertia times the rate of rotation for the student, dumbbell, and arm. And then you factor out the rate of rotation, and you just get the moment of inertia of the student, dumbbell, and arm times the final angular, the final rate of rotation is equal to the 7.45, which is the 2.4 times pi. Then, so to get the to find the moment of inertia, initially you do the initial total, which is they give you as 2.4, is equal to the initial moment of inertia time of the student, arm, and dumbbell. So first we're going to find the student. They give you for the arm, you're going to use the 1/12 mass times angular momentum squared of a rod, and then for the dumbbell you're going to do the MR squared because they're going in a hoop. So you're going to get 2.4 equals moment of inertia plus 1/12 times 2 times the mass of the arm because you have two arms, and then 2 times the radius, which was 0.65 initially because you have two arms, and then plus 2 times 1, which is the mass of the dumbbell because there's two dumbbells, and then same thing, radius squared. And so that's going to give you the initial moment of inertia for the student is 0.71 kilograms meter squared. And then to find the final rate of rotation, you're going to move back to this formula right here. So you're going to have 7.54 is equal to the moment of inertia of the student times and the arm and the dumbbell times the final rate of rotation. And the same thing for that you did initially, you're going to treat the arm as 2 rods and then the dumbbells as a hoop. And so you plug all those, and for this though, since he's tucked in, you cut the second, you have to use the second radius, which is 0.22, so you use that instead of the 0.65, and then the final rate of rotation is going to be 8.34 radians per second.